Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. The rise of hyperscale data centers has upended computing and network equipment business models over the past several years. The pluggable optics industry is no exception and has definitely been impacted. I'm fortunate enough to have as a guest today someone who has seen that transformation from the inside. This is episode 26, and we continue our second conversation with Ron Horan. You may remember him from a previous series of this podcast on silicon photonics. In this episode, we dive further into fiber cable infrastructure and get into the history of hyperscales. Ron attended the University of Texas at San Antonio for both his bachelor's and master's degrees. His master's thesis topic, entitled Synthetic Vision Landing Aid System, was patented as the first GPS-based aircraft landing aid. From 1994 to 99, while at Compaq, he earned 15 patent awards. In 2001, he joined Broadcom Corporation, where he managed field applications engineering for the compute segment team, ran program management in the networking BU, and was a senior director of sales and strategic account manager covering the Hewlett-Packard worldwide account. In 2011, Ron moved to Luxtera, where he'd worked as vice president of sales before moving into the role as vice president of marketing. Luxtera was eventually acquired by Cisco in 2019, where Ron now runs product management for the Cisco Client Optics Group. If you haven't already, please subscribe to this podcast. On Apple Podcasts, you would follow us now. We're part of the Cisco Podcast Network. Check out our blog at blogs.cisco.com and search on hashtag Cisco Optics Blog, all one word, no hyphens and no spaces. You'll find podcast notes and links there too. For our YouTube playlist, go to youtube.com and search on Cisco Optics. And for product information, go to cisco.com/go/optics. And now, join me as I talk with Ron Horan. What about breakouts? So, can you literally just swap out the hardware at the ends without touching the fiber? Or do you think that there are future upgrades that might require maybe some patch panel reconfigurations to accommodate various breakout architectures?
So,
is that a possibility?
Well, it kind of depends on what you mean by breakout. So in the data centers, you have what they call patch panels, right? And when I talk about structured fiber, basically what structured fiber really means is it's fiber that goes into the data center and they don't touch it. So it's all connected, it's all bundled up nicely and going through racks, on the top, and then eventually it goes to a patch panel, right? And the patch panel is usually, at where the switch is, like a spine switch or a aggregation switch or whatever. And what it does is it allows the data center operator to change. He doesn't have to touch that patch panel. He doesn't have to touch the fiber in the data center. But what he can do is he can, from his switch to the patch panel, he can change that out, right? And usually that's a run of, typically that's less than 3 meters. But for some of the other, some data center operators, there's different lengths. But the reality of it is, for each generation now, he can replace the optics and then use a patch cord between the patch panel and the optics to basically interconnect those. And that also allows the data center operator to be able to route that particular transceiver wherever he wants to. Think of it as like an old switchboard in the old, you see the operators plugging the things, that's right, effectively right. what it's effectively doing.
So behind these patch panels is basically the trunk cabling, which they don't want to touch once it's in there.
Right.
These are longer cables going through those cable trays throughout these gigantic data centers. They don't want to have to tear those out because that's a huge installation process, right?
So that's right.
So does that mean would they install more trunk cabling than they need today, in case in the future the transceivers might require a little bit more fiber than they're using today, so they can patch those in the future? Would they actually have have some buffer level of trunk cabling, or would they?
Because they basically bring the trunk cabling to a patch panel, and there's a connector in the patch panel. So, the trunk cabling goes to has a connector on the end of it, which plugs into the patch panel. And then on the other side, you plug into that connector from the other side. That they don't typically change out the patch panel. Now, there are customers who have tried to get rid of the patch panel, and they've tried bringing the optics or the cabling directly to the optics in order
Really?
to save cost, right? One thing that's really important to understand is, especially with the hyperscale customers, is that everything is about cost and price. And so because they do things in such, high volume that pennies make sense, dollars make sense. And so they basically, if they can save not having to put patch panels in, they'll do it. The problem is now you lose that flexibility. Now what you're doing is you're bringing the structured fiber all the way to the switch. And the problem with that is that that's great, but you lose the flexibility of being able to it doesn't always necessarily work. And so
So now you're stuck with that connector. You're stuck with that specific length, right?
That's right. And so the problem, and so some companies have tried doing that, where they've created specifications for these connectors that plug into the front of the module itself, and they've got instead of having 4 channels coming out of an MPO connector in the module, you've got 4 little tiny connectors that plug into the front of the module, kind of like a little patch panel. The problem is that's been tried, and I don't think it was very successful. So I think that the trend there is that basically people use patch panels. They're probably going to continue to use patch panels because of the flexibility it allows. It does create extra costs, but I think having to manage plugging every single channel into every single transceiver like that was found to be really, really difficult to manage.
Okay. I mean, that kind of makes sense. That flexibility seems really valuable because things are hard to predict, right? Even though you think maybe the deployment today is going to last a while, there's always something that's not going to go exactly according to plan. And so a little bit of flexibility
absolutely
can be really valuable, right?
Yeah. And so I think that I don't see that changing, the use of patch panels and structured fiber in the data center changing. Again, I'm talking in terms of generalization and the big hyperscale companies. The smaller, enterprise data centers may be different because they don't have the kind of scale that you do with the hyperscales, right?
Right. And so their priorities might not be exactly the same.
Right. What drives their decision making may be different. So my focus is typically on the bigger data centers. So that's tends to be what I know.
Can we go back to the history a little bit? So you mentioned hyperscale is like the data center type, but is really driven by these web scale companies. So when did this all start? Is there any kind of milestone for the first hyperscale data center, and what was the reason that happened at that time?
It would be pure speculation, but I actually looked this up at one point, and I want to say it came out. So, I think Amazon's been around since the 90s. I don't go and read the prospectus and try to figure that out, but I think they've been around since the 90s. Obviously, Microsoft's been around. Amazon's an interesting case because this is actually a really interesting story, which is, again, public information. I'm not sharing, proprietary information here. But Amazon started off as a retail business. As everybody knows, they probably everybody buys a lot of stuff from Amazon right now.
Mm-hmm.
And so they started off in the 90s as a retail business. And so what they would do is they basically would create these data centers for the purpose of supporting their retail business. And the thing about the retail business is that it's very spiky, right? So in other words, Black Friday is like Amazon's number one day, where just literally they basically, things go crazy, right? And in the past, they actually had trouble where people would be trying to buy stuff on Black Friday and they couldn't do it. And so consequently, and then there'd be times of the year where it's really slow, right? People aren't buying stuff. And so the problem was that Amazon had was they had to go build data centers to support Black Friday, because, obviously it's all about the sales, the retail sales, and that was their biggest day. And there's other days in the year that like that. But there's also where time, the majority of the time it didn't spike like that, right? It was more nominal, but they still had to go build for the worst case. And so they actually got the idea of, well, what can we do with all this extra, infrastructure and capacity for the rest of the year? And that's how they came up with Amazon Web Services, right? They basically said, well, why don't we host web services? And that's actually a true story. That's how they came up with the web services, to basically try to smooth out that spikiness. Now, I'm sure they still have that spikiness, but they're able to manage it so that they can take advantage of the capacity that they put in place, versus just having it sit there for 360 days out of the year, right?
So they had no choice really but to build for this enormous spike, which only happened like once a year,
a few times a year, yeah.
And then they're just stuck with all this unused capacity, and so their idea was, well, let's sell that capacity. So they built this new model.
That's exactly right.
They call it AWS.
Yeah, that's how Amazon Web Services came about. And I'm sure Amazon will probably say, well, that's not exactly true, but at a high level, that's what I believe happened. So, and so that's interesting, because you said you're talking about the history of how it cut where it was. That's just one example. And then, but you look at some of the the big hyperscales as defined by Light County or any other analyst. There's a big five, right? As defined by the industry as, Microsoft, Amazon, Facebook, Google, and Alibaba. It used to be the big four, but Alibaba and China's really coming up. And so, each of those, I'm sure, has their own story. I think Alibaba had a very similar story to Amazon, because they're a very similar business model. So it's kind of I'm sure that they got to where they are. Each of them has their own individual story, but they in order to support whatever business they were running, they had to be able to scale. And so now, if you look at, this public data on Light County.
That was the second part of my new conversation with Ron Horan. Next time, we'll get into industry growth and future trends. Subscribe to this podcast, and we'd really appreciate you helping to get the word out. Share this with friends and colleagues that come to mind when you think of network technology and optics. And leave a review on Apple Podcast. We're also on all the other major podcast platforms. You may see the Cisco Podcast Network come up when you search for Cisco Optics Podcast. That's where we live, and you can find other great podcasts there too. Also, check out the Cisco Optics blogs at blogs.cisco.com and search on hashtag Cisco Optics blog, no spaces and no hyphens. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. The next episode is part 3 of my conversation with Ron Horan. Until next time.